This is a summary on what I did last week. So far, we had finished everything about geometric sequence and geometric series. And I like to give this question from outside the book. It was a challenging question and a nice question. The question tells a winner on an American TV was offered one of two prizes, and this really happened. I heard that this really happened in America. The first prize is $250,000 in cash, or he has another choice: $1 first day, $2 second day, $4 the third day, and so on for 30 days. Which choice is advisable? Which one is more advisable? And why? Students started answering, of course, $250,000, and any normal person could answer $250,000. It looks much bigger than 1 plus 2 plus 4. But let's discuss this. I hid the solution for the time being. The solution was the first prize is very obvious, $250,000, clear. Second prize is 1 plus 2 plus 4 plus 8 plus 16 plus blah, blah, blah for 30 terms. This is the sum of 30 terms of a geometric series where r equals 2 over 1 like usual. This is already explained, which is 2. If we apply the formula, S30 equals A1, 1 minus r power 30 over 1 minus r, which is A1 is 1. 1 minus 2 power 30 over 1 minus 2. With the use of calculator, you get this very huge number, which is 1,741,823, which is a very huge number. Most of students, or all of them, answered 250,000. But when they knew the answer, they were shocked. And this was an amazing question, actually, and it tells us not to rush every time. So this is what we discussed at the end of part of the lesson. Now, when we come to the second part of the lesson, this part of the lesson, the objective is to find the sum of infinite geometric series. Infinite, not finite. If you have infinite number of terms. And also it tells us about how to use mathematical induction to prove statements. The question is to find the sum of all terms. You'll see what I mean by all terms of 40 plus 20 plus 10 plus 5 plus blah, 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 so on. All the terms. The number of terms is not finite. But notice that r is equal to 20 over 40 is equal to half. So after a while, the terms will be very close to 0 because this is 40, 20, 10, 5, 2.5, 1.25. The numbers are getting smaller and smaller and smaller, and they're getting very close to 0. So after a while, we're adding terms, and we keep adding 0 plus 0. We noticed something, and we discussed this with students as half, which is 0.5 power infinity. And I wrote here discussion. For any number between -1 and 1, the higher the power is, the closer to 0 you get. Like 0.5 here, power infinity, try 0.5 on the calculator, power 2, then power 3, then power 4. I let them try this. We get that, we noted that the numbers are getting smaller and smaller. So the sum of all terms is denoted by sum index infinity equals A1 into 1 minus r power infinity over 1 minus r, which is 1 into half power infinity, but half power infinity is 0. So the sum will be 40 into 1 minus 0, which is 40 over 1 minus r, and the formula is A1, this factor will be cancelled because r power infinity is 0. 1 minus 0 is 0, so A1 over 1 minus R. And this is applicable if and only if R is between -1 and 1. Otherwise, S infinity cannot be determined. And if R is between -1 and 1, the sequence will be called convergent. Otherwise, it's divergent. Convergent because the end of the terms will be 0, 0, 0. This is by agreement that they agreed to call it convergent. If it doesn't end at zeros, the sequence is called divergent. Well, let's practice this part. Determine if the given sequences are convergent or divergent. How can we know if a sequence is convergent or divergent? By finding R. 24 over 20 is 1.2. Not only this, 28.8 divided by 24, we already practiced this many times. We got sick of this. Equal 1.2. And this over this is 1.2. This is more than 1. It's not between minus 1 and 1, so this is divergent straight away. Then we don't talk about sum to infinity, infinite sum. Concerning part B. Part B is 1, blah, blah, blah. R equals 1/3 over 1 is 1/3. 1/9 over 1/3 is 1/3. 1 over 27 over 1 over 9 is 1/3. All of them give 1/3. In this case, 1/3, which is 0.333, is between -1 and 1. So this sequence is convergent. Then we can find the infinite sum. Find the sum of each infinite series if it exists. If it exists, how can we tell if it exists or not? By finding R. R equal 4 over 5, 0.8. 3.2 over 4 is 0.8. 2.56 over 3.2 is 0.8. They all give the same answer. So this is a geometric series that's such that R is between -1 and 1, so it's convergent. In this case, we can find the infinite sum, which is A1 over 1 minus R. A1 is 5, 1 minus 0.8 is 25. So if we add all the terms, we keep multiplying by 0.8 and we add all the terms, we get 25. Also similar question. We already discussed this, but not about infinite series. It's about like from 1 to 10 to 20. Find sigma k equals 1 to infinity of 2 over 3 k minus 1. This is already discussed. We need to find 3 or 4 terms to decide whether it's geometric or no. Replace k by 1. 1 minus 1 is 0. 3 power 0 is 1. You get 2 over 1. Replace k by 2. 2 minus 1 is 1. 3 power 1 is 3. This is 2 over 3. Replace k by 2. 2 by 3. 3 minus 1 is 2. 3 power 2 is 9. 2 over 9. And so on. Check R. 2 over 3 over 2 over 1 is 1 over 3. 2 over 9 over 2 over 3 is 1 over 3. 2 over 27 over 2 over 9 is 1 over 3. So this is a geometric series where R equal 1 over 3 between -1 and 1. This is convergent. And in this case, we can find the infinite sum. S to infinity equals A1 over 1 minus R. A1 is the first term is 1. 1 minus R already found here, 1 over 3. The answer is 3. Now, application to this, writing a repeating number as a fraction. How to write 0.5 bar as a fraction? 0.5 bar can be written as 0.5555 ... so on. We can find a way, by using a way, we can make a link between this number and our today's lesson. 0.5555 can be written as 0.5 plus 0.05 plus 0.005, then 0.005, and so on. This can be written as some of these. Notice This is the infinite sum of a geometric series with r equals 0.05 over 0.5, 0.1. 0.005 over 0.05, 0.1. 0.0005 over 0.005, 0.1. So 0.5 bar, this is sum to infinity of a geometric series, which is equal a1 over 1 minus r, which is 0.5 over 1 minus 0.1, you get 5 over 9. Check it, you get 0.5 bar. Actually, this way is related to the lesson, but in math we use a more general way and more applicable way. This is not related to the lesson. I like to give it to students. Another way, not related to the lesson. Let x be equal 0.55555. Since only one digit is repeated, then we multiply by 10. If two digits are repeated like 52, 52, 52, we multiply by 100. If three digits are repeated, we multiply by 1,000, and you'll see a variety of questions. Let x equal 0.555. Multiply by 10, 10x equal when we multiply by 10, don't use a calculator because I'm dealing with infinite, non-finite numbers. We move the dot to one place, you get 5.5555. Subtract them, 10x minus x equal this minus this. Also, don't use a calculator. Write them under each other, dot under dot. Here I have 5, here I have 5s. Here for x I have 0.5s. 5s and 5s cancel each other, so I got 5 minus 0 is 5. So 9x equal 5, x equal 5 over 9. The same answer as 5 over 9. Of course, we should get the same answer. I advise students to do this way, even it's not related to the lesson, because this question actually is seen in the SAT. This type of questions, they like it in the SAT. So students will forget formulas, but this way is not forgettable. So I advise students to use this way. Let's see some questions about this. Of course, I make like a discussion with students. 0.23 bars can be written as 0.23, 0.0023, 4023, and so on. Students ask questions how to change from this to this. I made things clear. Let's divide 0.0023 divided by 0.23. You get 0.01. Also, to make sure, 0.40s, 23 divided by 0.00s, 23 equals 0.01. So I made sure that this is the sum, this is the infinite sum of a geometric series with r equals 0.01. 0.23 bar equal s to infinity. This is the formula. A1 over 1 minus r. A1 is 0.23. 1 minus 0.01 equals 0.23 divided by 99. Students were happy to do this. Now, second way, the way I gave, let x be equal to 0.232323. We notice that two digits are repeated. Some students say many digits. No, I want the ones that are repeated, and I made it clear. 2, 3, 2, 3, 2, 3, so two digits. Multiply by 100, you get 100x equal. Move the dot two places. You get 23.23, 23, 23. Subtract them, 100x minus x equal. Write them under each other. 23.232323 minus 0.232323 equal. These cancel each other, 23. Calculator here is useless. It doesn't make any help. So I got 99x equal 23, x equal 23 over 99. The same answer as this. Okay, guys? So now I gave a question about this which was tricky in class, and this way was very tough. In this way, it's straight away. That's why I prefer this way. The question was 1.5212121, how to change it to a decimal using this way. It was very complicated, but this way as it is, the same as this way, no complications. Now, this was discussed during the week, and I gave, of course, many questions on these. This was during Sunday, Monday, Tuesday, and I think Wednesday. We started a new lesson. This lesson is just started yesterday on Wednesday. It's about permutations and combinations. It looks weird to students what the meaning of permutation is, combination. Students, it was a newly explained lesson. I like to introduce some vocabulary. Objectives of the lesson is to solve problem involving counting principle. This is a new topic. Permutations and combinations. This definition here, I like to start defining factorial notation. Factorial, this is a new definition for students. Factorial denoted by an exclamation mark. 3 factorial, scientific, agreed to define 3 factorial as the product of the numbers from 1 to 3. In the book and all the books, it's explained 1 multiplied by 2 multiplied by 3. I don't like this. I like students to start from 3 to 1, because later on I need this arrangement, not from 1 to 3, from 3 to 1. So students understand that 3 factorial is 3 times 2 times 1, blah, 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 equals 6. 2 factorial is 2 times 1 equal 2. 1 factorial is obviously 1, but 0 factorial is introduced as 1. And students ask questions, why is it 1? It should be 0. I told them this is by agreement. I wrote here for students, this is by agreement. Mathematician agreed that 0 factorial is 1 by agreement, and they could try it on the calculator. There is the bottom of the calculator, 0, shift factorial. They found out that this is 1. Let's continue practicing. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, if you multiply these, you get the answer. Or simply on the calculator, 7 shift factorial, you get the answer. 20 factorial or 10 factorial, I want them to get used to something. I want them to get used to n factorial. So I made this deduction. 7 factorial is 7 times 6 times 5, so on. 10 factorial is 10 times 9 times 8 dot 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 times 2 times 1. They didn't make any objection on this. No objection. 20 factorial, instead of listing all the numbers, we just simply write 20 times 19 times 18 dot 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 till 1. Now my issue is, what's n factorial? N is a number that we don't know. What's n factorial? They started answering like n times 1 or n. One of the students write n multiplied by what's the less than n, and I made them make the conclusion. Not all of them could make it. Some of them could write n into what comes before n. It's n minus 1, because what comes before 20 is 20 minus 1, which is 19. What comes before 19? It's 20 minus 2. So what's n factorial? Some of them could make it. N into n minus 1. What comes before n minus 1? N minus 1 minus 1, which is n minus 2. And so on. We stop at 1. So the conclusion is n factorial is n into n minus 1, n minus 2, dot, 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 till 1. Now let's make some practice on this. Simplify. What 3 factorial? 3 into 2 into 1, which is 6. What 7 factorial over 8 factorial? 7 factorial could be written as 7 into 6 into 5, blah, 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 to 1. We don't need to write everything. 8 factorial is 8 into 7 into 6, blah, 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 till 1. Mentally, without using calculator, we can cancel all the numbers from 7 to 1, up and down. I'm left with 1 over 8. And students were very, very happy to do this, and they could check it on the calculator. Another question, 9 factorial over 7 factorial. 9 factorial is 9 into 8 into 7 into 6, blah, 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 to 1. 7 factorial, I wrote it on purpose, 7 into 6 into 1 under these two, so students will see clearly we can cancel from 7 to 1, from 7 to 1. The answer is 9 into 8 is 72. To make sure they could do it on the calculator. 9 factorial divide by 7 factorial. They got 72. So I'm done with the factorial definition. But we need to do some practice about n factorial to n minus 1 factorial. I discussed with students that n factorial is n into n minus 2 into n minus 4, blah, 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 till 1. Now n minus 1 factorial goes, we start from n minus 1. Like in 7 factorial, we start from 7. N minus 1 factorial could be written as n minus 1, n minus 2, dot, 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 to 1. We cancel all the numbers from n minus 1 till 1, we get n. And students were happy to see this type of questions. This lesson is totally new. This is abstract math. Not dealing with numbers, multiply, add, write an equation of a line. This is abstract. We think of logic things. Let's simplify n plus 1 factorial over n plus 2 factorial. N plus 1 factorial should start from n plus 1. Here I had some questions. What comes before n plus 1? It's n plus 1 minus 1, which is n. What comes before n? N minus 1, and so on till 1. N plus 2 factorial is n plus 2. We start at n plus 2. What comes before n plus 2? It's n plus 2 minus 1, which is n plus 1. What comes before n plus 1? It's n plus 1 minus 1, which is n, and so on. Look at the common term up and down, from n plus 1 down, n plus 1 down. These are all omitted, cancelled. I'm left with n plus 2 down, with 1 up. So factorial now, how to use factorial in real life. Now students, the one that are attending the lesson, asked, how is this related to real life? I asked them, in how many ways can you arrange 3 different books on a shelf? If the books are named A, B, C, how can we arrange them? I start collecting questions. A, then B, then C, or A, then C, then B, or B, then C, then A, or the B, then A, then C, and so on. I counted the arrangement at 6. I could answer it very simply, 3 factorial, because I have 3 different books. I stress on the word different. If some of the books are similar, this will be discussed next week, inshallah. 3 factorial, which is 6, the same answer. So factorial is used to determine how many ways can a group of different things can be listed in a row, on a shelf, on a table, on a desk. Practice this. In how many ways can 5 different height students stand in a line? This is the same concept. I have a group of students of different heights. I want them to stand in a line. Not necessarily in an order. I could have the taller first, then the middle first, and so on. This is in 120 ways. Is it possible to answer it like this question? The taller than the less taller than the one from the back? So the answer is 120 ways. Another question related to this. If we have the 3 digits, how many numbers can be formed using the digit 3, 5, 4? Before they start answering this, I like to collect some answers like 354, 345, and so on. The total number of 3-digit number is 3 factorial, which is 6 numbers. And we made a discussion on this. So this is everything about factorial. How to use factorial. I repeat, factorial is used when you have a group of different things and we want to arrange them. I introduced another definition, which is combination. Combination is denoted by C, the capital letter C. The definition is Cm is n factorial, the one on the left, divided by m factorial multiplied by the difference n minus m factorial. Of course, students here couldn't understand the idea. The best way is to explain this through an example. 5 combination 3 is this one, 5 is n, and 3 is m. It's n factorial, the number here is 5, over m factorial, which is this number 3. N minus m is 5 minus 3 here, which is 5 factorial over 3 factorial multiplied by 2 factorial. On the calculator, they get 10. Here, the idea was very clear. How to find 7 combination 2? They knew it straight away. 7 factorial over 2 factorial multiplied by the difference, which is 5 factorial, 21. Now, how to use combination in real life? This is very good for statistics, for companies making statistics on things. There are companies, especially in the United States, just the whole job they do is to make statistics, and they give advice. They advise new companies. They make statistics to make a new advice on projects. Combination is used to know how many choices of n objects can be made out of m objects. Yani, how many shirts can you choose of 5 shirts? If you have 5 shirts and you want to choose one of them, one shirt out of them, I could choose the black shirt, the white shirt, the orange shirt, and so on. This is 5 combination 1. To make things very clear, I could read it as this is an agreement between me and my students. 5, choose 1. The word choose instead of combination made things very clear and very easy. 5, choose 1, because I'm choosing 1 out of 5. Just choosing. Question here. A menu in a restaurant consists of 3 types of sandwiches. So when you receive the menu, you can read 3 types of sandwiches: hamburger, chicken fillet, shawarma. 4 kinds of drinks. When you go to drink, you see 4 kinds: Coke, orange juice, mango juice, and pineapple juice. 3 types of desserts. The desserts could be namura and so on, whatever. A customer went into the restaurant and needs to order 2 sandwiches, 2 types of sandwiches, 1 drink, and 3 desserts. In how many ways can he do this? If we go to the menu, I have 3 types of sandwiches. He's choosing 2 sandwiches. We made a discussion with the students. The best way and the easiest way is to choose. I'm choosing 2 sandwiches out of 3 sandwiches. We read this one as 5, choose 1, and this can be read as 3, choose 2, 3 combination 2. And in math is multiplication. I have 4 kinds of drinks. I'm choosing one drink, so 4 choose one. 4C1. I have 3 types of desserts. Choose one. 3 choose one. So the answer will be 3 types of sandwiches. I'm choosing 2. 3 choose 2. And means multiplication. 4 kinds of drinks. I'm choosing 1. 4 choose 1 and 3 choose 1. 36 choices. This was the answer for this question, because I'm choosing 2 sandwiches out of 3, 1 drink out of 4, 1 desserts out of 3. So the answer is 36 choices. This is about combination. So we stressed ideas. Factorial is used when I have a group of things, group of different things, and I'm arranging them. Combination is used to choose small group out of a big group. So far, they got this idea very clearly. Now, I introduced the last term in this lesson, the last vocabulary, which is permutation. Permutation is denoted by P, the first letter. NPM, the definition is n factorial over just the difference factorial, n minus m. Like in 3 permutation 2 is 3 factorial over 1 factorial, 3 minus 2. 5 permutation 2 is 5 factorial over 5 minus 2, which is 3 factorial. With the calculator, there is a button next to the combination. This is 6, this is 20. Now, how to use permutation in real life? Again, I like to repeat things so students won't get mixed between them. Factorial is used to know how many ways we can arrange n objects on a shelf, in a row, in a line. Combination is used to know in how many ways we can choose small group out of a big group. Permutation is used to choose n objects out of m objects and arranging them. Yani, if I have like 50 players, I want to make a team of 11 players. In how many ways can I choose 11 players out of 50 players, and the 11 players will play a football game? I want one of them to be goalkeeper, one of them to be right wing, left wing, mid player, and so on. After choosing the 11 players, I want to make an arrangement out of them. So this is choosing a small group out of a big group and arranging them. This is permutation. A permutation is used to choose n objects out of m objects and arrange them. Like a box contains 5 different antique pieces. You have 5 different antique pieces. In how many ways can you choose 2 pieces and arrange them on a shelf, on a table? After choosing the 2 pieces, like I got statue and a house antique, I could could put the statue here, the house here, or the house here and the statue here. After choosing 2 out of 5, I need to arrange them on a shelf. This is 5 permutation 2, which is 20. And I repeated to students, I made them distinguish between factorial, combination, and permutation. My questions were, when do I use factorial? Here I got a mess of answers. Most of them, they could know that factorial is used when I have a group of things that need to be arranged. All of them need to be arranged on a shelf, group of different things. This is n factorial. Combination is used when we just choose a small group out of a big group. Combination can be read, this is an agreement between me and the students, as choose. If we just choose without arranging, this is combination. And permutation is used when I choose a small group out of a big group and arranging them. Example, and this will be discussed next week, inshallah. In how many ways can I choose a manager, a clerk, an auditor out of 10 volunteers, 10 candidates? 10 candidates applied for a job. In how many ways can I choose 3 of them and assign them, one as a manager, one as a clerk, one as a auditor? This is 10 permutation 3, because I could choose the 3 volunteers. Could be Fadi, Muhammad, Ali. Fadi could be manager, Muhammad could be clerk, Ali could be auditor. Or Ali could be manager, Fadi could be clerk, Muhammad could, Ali could, and the other one could be auditor, and so on. After choosing 3 candidates out of 10, now the problem is how to give them the jobs. This is permutation. This is a very clear idea. Okay, this is what was discussed this week. So for next week, inshallah.